Everyone here today. And we're so excited to welcome Dr. Christine Cunningham and Dr. Katie Bateman from the Museum of Science in Boston with us to talk about this Youth Engineering Solutions out of school time curriculum. I know I was recently at a conference and was telling people left and right about this curriculum, and everyone was so excited to hear about it. So I know I am particularly excited to hear about it from the mouth of the creators, so to speak. So Dr. Christine Cunningham, of course, Museum of Science Boston. She is the Senior Vice President of STEM Learning. Did I get that right, Christine? Yay, good job, me. And then Dr. Katie Bateman, of course, who's the Professional Learning and Research Management at the Museum of Science of Boston, with Dr. Cunningham, of course. And with that, I think, and I am Becky Swanson. Sorry, I should introduce myself. I'm Becky Swanson. I'm a STEM specialist and assistant professor at University of Nebraska-Lincoln with 4-H youth development and part of the team for Click to Science and Click to Engineering specifically. So just so you know who I am too. We also have my fellow team members, Ann O'Connor and Sandra Frericks here as well, joining us today to hear about this curriculum. So with that, I will hand it over to Dr. Bateman and Dr. Cunningham. Christine and Katie, it's all yours.
Great. Thanks so much. I don't know if Christine, you want to say something before we get started. Just that first slide is just kind of this, who are we and what we do, if you want to kind of give everybody a summary.
Go ahead and start.
So the YES curricula and professional learning empower educators to create classrooms that engage all students in authentic, hands-on engineering challenges connected to their lives and their communities. And so today we're going to focus on our YES out-of-school curricular units that are currently available on our website. But just in case anybody is also working with in-school, we do also support pre-K through our We Engineer program and elementary and middle school in-school classrooms. So if you are like, hey, this would work really well for my teachers who support kids during the day, we've got you covered on that part as well. So one of the things that has been looked at through our team is this idea of like, what do kids actually think engineering is? I don't know about the rest of you. It was not a thing that was part of my K-12 experience, or I say all the time, my teacher preparation program. We didn't really talk about it. If you had asked 10-year-old Katie what an engineer was, I don't know that she could have given you an answer, right? And so the project asked students between grades K and kindergarten through 12th grade, 700 of them, to draw pictures of engineers at work and describe what that engineer was doing. And so students gave all kinds of answers, right? They said that engineers are construction workers who build buildings, that they build bridges and roads. Now, not that they designed them necessarily, but that they built them. They created these bridges. We also learned that students think about engineers as auto mechanics, which that kind of makes sense, right? Engine, engineer, very similar terms. So students think that engineers must work on cars and fix engines. They also think that engineers are people that you call when your computer is broken. So your geek squad, they're engineers. And we were not surprised to learn that the youngest children even thought that engineers drive trains, right? We use that term engineer. It doesn't always necessarily align with the practices of engineering. Sometimes that term gets used as such, like a sanitation engineer, slightly different idea. And so really what we found is that a lot of children don't have very accurate or complete understandings of what it is that engineers do. And so helping youth develop more comprehensive ideas about engineering and technology should be one of the foundational principles that STEM instruction nurtures. So that kind of also brings us to this question of, well, then what should engineering education involve at elementary and middle school levels? And one of the things that we have developed is this idea of an equity-oriented engineering learning framework. And so we think about this as foundational to the model for the curriculum. So this is embedded, this is the baseline of where we start with all of our different curricular products, including out of school, but also the rest of them. It has 4 domains, and each of these encompass different principles that structure the resources that we're developing. And so the model communicates how engineering learning, knowledge, and facility with engineering concepts, practices, and skills can be developed through more equitable approaches. Carefully designed curricula facilitate youth participation in socially engaged engineering. There's your red pie wedge there, relevant to their lives, community, and world. Through analysis and design regarding these applied problems, youth learn to use engineering knowledge as they engage in authentic engineering practices, that little blue section. And this participation and engagement are facilitated by asset-based pedagogies, focusing on the strength youth bring to that engineering context. And so there's your green pie wedge. And the model depicts the development of a positive, generative engineering identity that's built on substantive learning of an engineering knowledge and classroom discourse that situates youth as competent and engaged engineers. And we're going to visit these different domains throughout our time this morning together as we discuss these units that are available to us. And we're going to start and really focus on our grade 3 through 5, so our upper elementary unit, engineering rescue shuttles. And in this unit, students are really thinking about the problem of someone needing to be rescued, in this case, a water rescue, and rescue workers not really being able to reach them directly. They need some kind of engineered solution to get a rope, a device to them, the people who need rescued, to be able to pull them to safety. And so each of our units starts with an activity called What is the Engineering Design Process? We're going to talk about that a little bit later. We're going to focus on activities 2 through 5 and A through D. So they are designing a solution over the course of those first 4, the activities 2 through 5, the first 4 activities. And then there are 4 supplemental activities that enhance the engineering design challenge in the out-of-school time problem. We recognize that out-of-school time doesn't have quite the structure that in-school does, so we've embedded this flexibility for these supplemental activities that can be kind of done in whatever order they need to be done in to meet the needs of your programs. And so I wanted to show you the beginning of rescue shuttles in one of our field test sites. This is a little bit of a longer video. It's the only long one I have. But this is an after-school program at a school in Mayagüez, Puerto Rico. So all of these students are emergent bilinguals or emergent multilinguals. And we're going to listen in on some clips from the very beginning of the unit, from the first day, as the students are getting ready to engage in this engineering design challenge. And so thinking about that equity-oriented framework, I want you to listen for the ways in which teacher Nora, that's her name, and her students are embodying some of these equity-oriented framework components as they're going. You know, what we didn't check is sound, so hopefully we're good here. Let me see. Let me know if you can't hear what's happening.
Now, we are going to start with engineering rescue shuttles. What you can see in this picture, so we can have an idea what we're going to be doing. Camilo. With what? Con un salvavidas, a lifesaver, right? What happened? What it says, Diego? ¿Qué pasó, Damira?
Can we talk Spanish?
Talk like we always do, mommy, okay? I know that some of you in science, you know that when we get ourselves stuck into some concepts, we can speak Spanish so we can help each other with the language, okay? Remember that you are learning and growing. Yes, Yanel? Mm-hmm. What is he doing? Regina? And this kind of weather, can we find it here in our island?
No.
But in our island, we have this happening too. Who can tell me when we have this kind of rescues? Francisco.
There's a fire.
When we have fires, but what we have here in this case? Someone that is gonna drown, right? Huh? In this case, it's frozen, but in our town, in our island, when people does not know how to swim, and you know how many times we hear that there's una crecida, when the river levels, they go higher very quickly. So when this happens, there are some people who rescue them. So what we're gonna do in this unit is we're going to become engineers. Understood? You are not kids here. What you are now? Engineer. In here, what do you think that we have here?
A planning circle that we can, like, first imagine, plan, create, test, ask.
Okay, so in here it's a circle, right? And a circle moves. We can go back and forward, right?
But now the circle is full.
In this case, we are starting the circle, and it starts in. Remember when we talked about scientists? Scientists follow a process, right? Engineers follow process too, okay? And we are gonna be following this step by step like guide, but they mix up. Sometimes I have to ask, when I ask, I have to imagine and all the things there, okay? Through this unit, we are gonna be doing all those different tasks. For this, we are going to have each activity, some of them we are gonna have a comic book, okay? Where we have a situation and we are going to start doing the things, okay? Let's see. If you have trouble with it, I have it in Spanish too. So if you want to, we can test both, okay? If you want that.
So what do we notice her doing? So if we think back to those equity-oriented engineering learning, we have our socially engaged, we have our asset-based pedagogies, we have our authentic engineering problems, and we have our engineering identity. Did you notice any of the things that were happening in this? Yes, a little bit longer. None of the other ones are that long, I promise. Clips, what was she doing that kind of allowed her to embody those pieces of the equity-oriented framework? And so we can use the chat. Becky, do they have the ability to raise their hand in this one, or can we just use the chat?
I believe so.
Okay.
Or anybody can just, I think, unmute. We have
Unmute,
settings
perfect.
set pretty broadly.
Yeah, she makes a real effort to help the kids connect the idea that will be their challenge to their own experience. Yeah, this teacher was really masterful in this, in making that socially engaged connect with them directly in their experiences as she goes through the unit. She's constantly bringing them back around to things that are either local to their specific community or local to the island of Puerto Rico that really help the students make that connection, right? It was something that was important to them because they knew people who were going to need this device. This was something very specific to their context that they were living in. Anybody notice anything else?
I was gonna say, I was very impressed with both how she situated, I'm making an assumption here, sorry.
Yep.
She situated herself as a learner of language while also, I'm not going to say this quite right, but making it very okay for kids to speak in whatever language they were most comfortable with. And acknowledging that, like, we're all learning. I love that we're learning and growing, like that you were all learning and growing. And that was, I thought that was a really masterful teaching move there.
Yeah, she really leverages this translanguaging that's happening in her classroom to allow every student to come as they are, and engage those assets that they bring. So instead of their, having maybe a less masterful grasp of the English language, that didn't become a barrier for them. It became an asset that they spoke two different languages. And you'll hear her a lot of times, if we're listening to these clips, you'll hear her repeat things in both Spanish and English. So if a child says it in Spanish, she'll say it back in English and vice versa, so that everybody was working on not just their STEM, but their language learning as well. But it also allowed every student access to what was happening, regardless of the level of English that they were working in. Yeah.
One of the other things I noticed, it's a little bit more subtle, but this idea that engineering is about helping people. And the challenge is something we can do to help other people. And that wasn't real obvious in this one, but it came across, as we're talking about what engineers do,
Mhm.
it was about helping people.
Yeah, and that's that socially engaged, right? That it is a real world problem. It solves a problem for some person, and we make it really tangible, right? These are now they're going to meet, we'll talk about the comic characters in a little bit. They're going to meet comic characters, so they're not tangible people, but they make those connections with these comic book characters that they're, real enough that they want to help solve their problems. And in this case, they're solving problems for their own community as well, because people, they like to tell stories, as most 8 to 10-year-olds love to do, and have told us every story about everyone who's ever needed a water rescue in their lives, right? And it made it important to them. So there's that socially engaged piece. Excuse me. So one of the things that I also like to bring up is this idea of curriculum is lived by teachers and students. It's not just experienced. So it's always going to be need to be connected with the reality of the classroom culture, both in terms of the design challenge locally and in terms of how you carry out that experience. So we see her making these connections to, yeah, that pictures of a frozen, tundra, which isn't the same as our local context, but how can we connect to that, as well as thinking about the language that they're using and the resources that they need. We're going to take a closer look at the scaffolds to do these things as we go through this unit, and we'll revisit Teacher Nora and the youth in her program, and we'll focus a little more on the practices as we go through, because it's a little harder to see that in this kind of build up to being able to engage in the unit, but it's there. It's going to try and play this video again for me. Come on. Thank you. So we also I wanted to make clear that we use a developmentally appropriate engineering design process. And so there's less steps when we're thinking about preschoolers, right? We just have those three. They're going to explore, they're going to create, they're going to improve. And at the middle school, it gets a little more complicated. But we're going to focus on the elementary version of this, so grades K-5. And you'll hear the students start to use this. And we saw Teacher Nora introduce this already, that this was foundational to the unit that they were going to be engaging in. And this kind of idea of the flexibility of it, that there's a structure to this, but also that we're going to move in between these different phases. And so the students will move fluidly through this, even though the specific stages are highlighted in each activity support educators' facilitation. And so as we visit kind of each of these lessons in turn here, you'll see a variation of this same graphic show up that'll let us know kind of the highlighted phase of that particular lesson. And that's made clear in the curriculum resources that teachers have access to as well. And so we're going to talk a little bit more about that socially engaged engineering right now, right? So part of our approach is to design our curriculum with this socially engaged engineering in mind. And we've distilled this down into 3 principles related to that: to situate the problem in a societal context, consider the impact of problems on different individuals, groups, or systems, and thinking critically about the impact of those engineered solutions. And there's many ways students can forge meaningful connections between their lives, communities, cultures, society, and engineering. And stories are one powerful tool for situating a problem in a larger context and understanding its importance. And so key to the way that we think about developing curricula is the context setting. And so we saw already with Teacher Nora and her students how important this setting of a context was. It was something they connected to. Why do we need to design this thing? Why is it important? So with our earliest elementary students, those, kind of kindergarten through 2nd grade, we have a read aloud story poster. So there's a big, you print out a big poster, and there's little characters and things that move in and out of the setting. And there's a little read aloud story that helps accompany that. At the upper elementary, as we heard Teacher Nora mention, the students read a comic that can be used as the teacher sees fit. We've seen this where students read independently, and then they use the discussion prompts to talk about it. Teacher Nora has the students take turns playing the different characters and reading it aloud. In some cases, when students really needs more scaffolding with the reading process. We've seen teachers read aloud and the students are following along in their own comic. In middle school, we use a video to help identify the problem with real-world engineers. And in all of these, we have discussion questions that we provide to teachers to help engage the students in making connections to this context. So in engineering rescue shuttles, students meet Aisha, who works at the engineering help desk. We see her in the comic over there on the right side. And several different characters present Aisha with problems for the engineers, meaning the youth, to solve, including engineering the rescue shuttle, but also engineering a waterproof bag and a glider. Additionally, we also see on the left-hand side here, there's a video to help connect students to the real settings in which these technologies may be of use. So we recognize that not every student is going to live in an area where flooding poses a threat to the community. So we want to make sure that they get the gravity of this situation. So this particular one is looking at Tibet and flooding that had happened there. And even in these students in Puerto Rico who experienced this personally, were very moved and empathetic with the people in this video of like that this was a horrible thing that was happening to these people and how they needed to connect to it. And so we get to the first of the ask phases here. The first two of the ask phases here, excuse me. In the first phase of that design process, the students ask, which for rescue shuttles means determining how different variables will affect the flight distance and path of their shuttle. And so 4 variables are tested over the course of 2 activities. And we see them here: the material for the shuttle body, the length of the shuttle body, the number of fins, and the placement of the weights. And with the exception of the materials, those graphics also appear in the student-facing resources to help students make those connections to what it is that they're making adjustments to. And so this is where we start to really bring up these engineering practices. Part of this equity-oriented framework is making sure that they engage in these practices. And we've identified 16 that engineers use in their day-to-day practice. Some of these are specific to engineering and STEM, such as applying math and science knowledge. And some are mindsets we want all students to develop, regardless of whether they become an engineer or not, such as persisting through failure and working in teams. And so as we walk through the engineering design process in rescue shuttles, we'll see this pop back up, and I'm going to literally highlight, you'll see in a second, practices that students are engaging in that particular lesson. So in this first, in these 2 ask activities, we really see the students start to consider the problem in context, this idea that we need a solution to a problem, and they're exploring the properties and uses of the different materials before they get to their design so that they have shared knowledge. They don't need to come with any prior knowledge to do the design challenge. So we make sure that everybody has equal access to being able to complete the engineering design challenge. And so one practice that's really important is to consider criteria and constraints. And we'll look again at that. That'll show up on the next table of practices there. And so to engage as engineers, students need to understand what a technology needs to do to be successful. They need guidelines. Engineers think about criteria or the requirements and the constraints or the limitations of a design and balance trade-offs between these 2 things. Similarly, students' designs should be guided by a clear understanding of the task. So generating a list of criteria and constraints through investigations or research in the ask phase and posing this for reference can enhance youth's designs. And so for rescue shuttles, students are introduced to the criteria prior to imagining their shuttles. The shuttle needs to land in a target zone of their choice, and they can only use the materials provided. It's simple, but it gives them some guidelines as to what they can and can't do and what they're expected to achieve. It provides a goal for the youth. The ask phase will have helped them to gather the knowledge they need to meet these criteria and constraints. And so here we see the criteria and constraints for rescue shuttles right on the Imagine page of the youth engineering notebook. And so in the Imagine phase, we ask students to work independently. And this goes counter to the fact that right there on this slide, I have work in teams, communicate. And there's a very specific reason why I'm always very specific about this when I talk about the imagine phase, is that we want every student to have the ability to think through and come up with their own designs, to be able to share that as they come together in pairs or triads or quads, depending on the configuration of the unit, to come up with a design. One, we want them to envision multiple solutions. That means that everybody needs a chance to think. We want them to be really thinking about what they would do. And some children are not going to jump right in and shout their ideas out to the world. Some children also just need more think time. They need a moment to process and think about what it might be. By having them do this imagine phase as an independent, quiet thinking activity, like put on your soft music and let them think, it also gives the teacher a chance for the students, when the students have drawn their model of their shuttle, like we see at the bottom of the notebook page there, as the teacher's then walking around and supporting youth as they engage, it gives the educator a reference point to mention. So we've seen this where an educator will come around and say, I see what, Susie has written. Have you talked about Susie's design yet? Susie may not be the kid that jumps right in and shares her ideas, but it allows then an entry point for her to have both thought about what she might say and a scaffold for the teacher to build those connections when we do get to those communicating and working effectively in teams. And so again, we see the balancing criteria and constraints. And we also have this idea of making evidence-based decisions. We want them to take the information that they gathered in the ask phase as they're thinking about what they might use here. So we see reference now, this is real student, notebook pages. We do see them say wings instead of fins. We see them say washers instead of weight, but they're on the right path. They're using these ideas as they're thinking about the design that they might want to make. And so again, this is their imagine stuff. And so we come back again to this idea of socially engaged engineering. We further put some contextualization in. We saw on the last slide, and I'll pop back real quick, this idea of the different zones that they will be shooting for. They're not just zones for the sake of zones. Those zones have very specific people with very specific needs that they want to meet. And so we give students a choice here. Which group of people would they like to design a solution for? We have a little boy and his dog who need rescuing from their roof as the water's rising. We have a flood waters washing out a path, but the river water is rising. And then we also have a farm where the animals need some guidance to get through the rising water and be rescued. There's not one single design that's going to meet all of these needs. So students have to be thinking about multiple users, and they have to be thinking about envisioning different solutions and multiple solutions to meet the needs of these different places. And so then students get into their planning, right? This is where they get into that working effectively in teams and communicating effectively. And so again, we have a planning page from one of these engineering notebooks where students have used the talk prompts that you'll see. I think you can see my mouse. No. At the top of that page, we see these talk prompts that are in there to help scaffold that communication and teamwork. A lot of our students, especially now this 3rd through 5th grade, who went through kindergarten, 1st grade during COVID when they weren't allowed to talk or touch or really interact, they need that scaffolding to be able to develop these effective communications and teamwork. And so we have found that these sentence stems, these talk prompts are really helpful for students. And it's always funny when I will hear them and I'm watching video back and I'll see, we could use, and they like pause and then they'll come up with something, right? They're using these as a way to start the conversation and engage in the engineering activity. It helps to focus them and really give them that ability. But it's also helping them to plan here and use that structured problem-solving process as they're thinking about the different variables and they're thinking about what is this sort of shopping list of materials that I need to request from the educator in order to complete my design. They then move on to that creating and testing, right? So here's that structured problem-solving process. They have a testing page, really simply able to collect information because we're going to get into that and prove, and they want to be able to further make evidence-based decisions. And they're also thinking about applying their science and math knowledge to the problem solving here. It was a really interesting thing that happened in this classroom is that the students realized very quickly that the tiles on the floor were 12 inches. They were a foot. And so they were able to solve this problem of we're still measuring feet, but now I don't need to have my tape measure out every time. I can just count the number of tiles that it went. And I can use that. So there's this interesting kind of math problem solving, right? I don't have to pull out this giant tape measure every time. I can just walk down the tiles, and they all started counting together, right? You would hear this like 1, 2, they were very helpful to each other. I will say that about them. So they're thinking about, how we're using these things as we're testing. So I also want to then highlight these asset-based pedagogies that start to happen here with this structured problem-solving process. So that third dimension of asset-based pedagogies are ways in which students can be viewed in a positive light as having value, which they bring to the table in engineering classrooms. This includes building on their experiences and knowledge brought from non-school context, supporting their developing vocabulary related to the engineering design process, and the challenge to open opportunities to use that knowledge in disciplinary aligned ways, and creating design challenges and accompanying materials that provide multiple ways for students to share and document their designs. And so we're going to see, again, much shorter videos now, a short video clip in which these two youth, these two little girls, have just participated in engineering rescue shuttles. And they're going to share how they were able to leverage multiple modalities in order to express their ideas and to become familiar with the terminology of the engineering design process.
We talk to people, we draw them kind of in the paper. We have to draw them and do the plan, like in the engineering process to do. But we do the plan, the imagine, plan, create, whatever. The goal and test. What if what? Combine tape and paper to do I know, don't touch it. I like talking to things because I'm drawing it, and I like to them because then I have an idea what I do.
And so we hear this little girl on the left telling us about how drawing her ideas allowed her to recall what it is that she was planning to do. And that was her design that we saw kind of pop up very briefly for one of the activities that was part of her waterproof bag design. She was able to draw it out, and they label these designs, and they're able to then recall what it is that they had planned, especially when we have breaks between sessions. So for these students, they came back the very next day after planning their rescue shuttle and then started creating. But we know that sometimes in our after school programs, it may be that STEM is a once a week activity. We may have students who are not there every day and need to pop back in. Having these opportunities to write, draw, sketch allows them to document these ideas and revisit them later. Okay, you're going to do that. That's always a fun one. Come on. Nope. There we go. And so the final stage or phase of, as Rahina put it, the wheel of the engineering design process is to improve. A really critical piece of this engineering design process, because we want students to fail and persist through that failure. By having this improved phase, it allows them to know that if I don't get to my goal the first time, I have those opportunities to do it again. That this is not an end point, this is just a stopover. And tomorrow I'm going to get to come back to my rescue shuttle, think about what I've already learned today, and use that information going forward. And so in this improved phase, they're innovating to design solutions. They're taking what they know, or in some cases, what their classmates know, what they saw other people do in their rescue shuttle design, and use that to take their design and improve it, make it better, and try to reach their goal. But we also see them then start to identify as engineers, and we'll take a look at that in just a second. But I wanted to show some a student, and we're going to get to meet Alana in just a second. But you know, not every design works the first time or the final time. So real engineers know and embrace the idea that failure helps learn what works. And engineers learn from failure to revise and improve designs. This requires persistence and improving through multiple iterations. An engineering process, again, that built-in improved step can signal to youth that they're expected to try again. So we're about to watch another little video where two students, Felix and Alana, will share with the whole class. This is kind of pieced together of their sharing out at the end of their testing phase and their improving phase. And we're going to see that conversation. But here we see snippets from Alana's engineering notebook throughout the planning, creating, and testing and improving phases. And we see how she imagined her shuttle over here. Their testing results, they did not meet their intended target goal. And we see her reflection even on her improvement. You'll see she wrote, still failed. But we're going to see the attitude and mindset that went along with this, because looking at just this document, you could think that this may not have been a positive experience for students. And that was anything but the case.
How did you flip the failure today? How did you work on it?
So that's Felix.
In your mind, how was your mindset? It was positive, it was negative.
And that's Alana.
Huh? For the teams that didn't arrive on the target, how do you felt?
Because I didn't think it was gonna be that hard.
But what happened in the instant? Do you stay like down, like you don't want to do it again? So what your mindset was?
I'm gonna do it again. I'm gonna try again.
Very good. So the same thing happened in the comic. They tried it again and again. And this happens all the time with scientists and with engineers. Not everything is gonna be perfect at the same time. And it happens to you every single day, right? Every single day you have to have a good mindset. What changes did you make to get your shuttle to land in your target zones?
Took the weights and I didn't want to spin because it didn't go so far because of the weight that was putting it down. And also because
So you make it more lighter and place just one wing, more fins. Do you have fun today? I can change.
4.2 or 5.
Out of 5.
These are the first things together. Yes, I did 4.9.
Why 4.2? You didn't went to the thing, so.
So we see a lot of things happening here with Alana and Felix. We see them persisting through failure for sure. We also see them using those evidence-based decisions. They're using their science information. They thought about the fact that the weight may be the thing that was holding their shuttle from getting to the targeted zone. But we also see them laughing. You see them when they jump on this launcher and it doesn't quite work. They're frustrated, but they're not unhappy. They're laughing about it. They're smiling as they're going through it. And Alana tells us at the end, it's a 4.2. It's not as good as yesterday, but it's still above, 4 stars out of 5. So I think we'll take that as we go through it. Oops, one of these days that's going to work. So persisting and learning through failure is really one of these important engineering practices. But it's also really key to that engineering identity, is understanding that this is part of being an engineer. And so here we have some screenshots from other students in this same classroom talking about that engineering is just a thing. Failure is just the thing that is part of engineering, and it's how they learn and it's how they grow. So it's not something troubling or bad. It's just part of the process of learning. So after that, that's their initial engineering design phase, we also set up these opportunities for students in these supplemental activities to continue going through these engineering design processes. And so in activity A, they engineer a waterproof bag. And I will say this, they could not get enough of this. This became a 2-hour activity because they were so excited about doing this, and trying to figure out what went in the bag. They had a blast. So we see that picture on the left there. And in another activity, they're thinking about engineering a glider. So how do I get supplies to somebody that may have some time before a rescue worker can get to them? And in this case, it's people who have been hiking and they're up on a cliff and they need to send it. And so they're really thinking about the shape of a paper airplane and what weight it can carry in order to reach the targeted zone, similarly to their rescue shuttle. In activity C and D, there's less of that hands-on engineering, and it's more about really supporting that engineering identity and involvement of the community. So in activity C, we have them try to make career connections. We leave that open with scaffolds for educators to bring in community members, whether it's an engineer or a rescue worker, in this case, somebody who's engaged with the problem directly. And we see here questions that the students are generating, whether they're engaging with a real engineer in person or they're working with some of the videos that we provide if you don't have those resources available. And then the last bit was a showcase, a way for parents, community members to come in and see all of these wonderful engineering things and let the kids show off. Let them show how they are engineers and that they can engage in these processes. And so really thinking about that engineering identity through those last two, educators can nurture engineering identities in a number of ways. Successfully participating in engineering design challenges shows youth that they are capable of engaging in such work. As youth engage in engineering activities, educators can make connections between the work they're doing and the work of engineers. For example, referring to the work that youth are engaged in as engineering and the youth as engineers helps members identify their efforts in that way. And we heard teacher Nora already doing this on the first day. She told them they were engineers. So we started off looking at how she set it up, and we're going to wrap up our talk of rescue shuttles with the interviews of a young boy and the teacher and their experience with the engineering unit.
He is a student who struggled a lot with English since seeing him reading English confidently, helping everything, and seeing him so happy because his shuttle went through this and seeing that he created something that it went perfectly. He was super excited about it. After that shuttle, the next day he was more confident in what he was doing.
What do you really like about the rescue or the coedes?
Everything.
Everything. Tell me
Everything.
more. Tell me more about what does everything mean?
All the things. All. I like to wear. I think I'm gonna be un ingeniero because I like all of the things que tienen que ver con electricidad, con cosas que dan vueltas, cosas que prenden como las luces. A mí me encanta todo lo que tiene que ver con ingeniero.
Okay, so you like the engineering aspect of it, and you think about other areas of engineering.
Yeah, I like airplanes.
You like airplanes? You said you like something about electricity, electrical engineering. Do you think you want to do this type of activity again?
Yes.
Yes?
Totally yes.
And why?
Because it was super
fun.
cool. I
love engineering.
I like
Cool.
to be like different things every day. I want to meet new people. I like to look new things. I like to saber más ingeniería, sobre ingeniería, todo.
Yeah.
Yo me levanto y digo, ay, ojalá que aprendamos algo nuevo en ciencia.
And so we see this young boy really identifying with engineering, wanting to take this up as a future career. But we also hear the teacher talk about the fact that during the regular school day, he really needs a lot of scaffolding to participate in reading and in math and these different subjects, where it doesn't have this flexibility that engineering does. But he was elevated not only by the teacher, but by his peers. So Felix and Alana, who we met earlier, who were struggling with their own failure, one of their strategies in improving was to go ask Yael, this little boy, what it was that he did, because they had seen him be successful. And so not only did the teacher position him as an expert, his peers started positioning him as an expert as well, and he felt like an engineer. Nope. One of these days, it's going to not play the video again when I try to change slides. So here's our next kind of reflection point is, in what ways can we promote engineering identities in our programs? So as you're working with your own engineering, your own after-school program or out-of-school time program, how can you promote engineering identities with your students? You can put it in the chat or unmute and chat with us.
Well, I will just say, I mean, as somebody who doesn't unfortunately get to be in front of kids very often right now, but I will say what I see other people doing is very much as we saw in this first video, right, where the teacher very specifically says, you are engineers, you are doing engineering, you are being engineers. I don't know what the effectiveness level of that is, but it certainly just in, you know, like I like it seems to be convincing the kids, and I see them taking up that language in classroom spaces and out of school time spaces where I see educators saying that. Yeah, so that's been my main experience with it.
Yeah. So I will say one of the things that I come back to all the time is helping students with that idea of failure, and that this is okay and this is a part of the process. The students who we often find in these classrooms who are super successful in the engineering design process are your students like Yael, who need a lot of scaffolding and support in their everyday classroom, your kids who have IEPs and special needs, your students who are neurodivergent, whether they're ADHD or they're autistic, because they think outside of the box, and B, they've learned to be resilient and continue. Sometimes the students who need the most scaffolding and support in this persistence are actually your high achieving students that you would normally not need to support in these ways, but failing is not normally part of their day. They're used to being successful. And so they need those additional identity pieces of, this is what engineers do. This is part of the process. Sandra's saying she likes to focus on solving problems, that kids are able to solve problems and they can connect the engineering being about solving problems. Absolutely, right? Troubleshooting in the more minute pieces of it, but just this big idea of, this is a problem. People are drowning and we need to help them. And they really do like these contextual problems. I will say one of our in-school ones works with dogs that do not have homes and need to be fed. And they're very concerned about the dogs, that this is a problem and they want to fix this problem. You also get the child who then will say, what about cats? And it's like, that's not the problem today, but we can also think about the cats. That's fine. So thinking about things that are meaningful to them in that problem solving. And so we wanted to just make sure we also talk about some of these other units, and I'm going to continue to highlight that equity-oriented engineering framework as we go through. So right now, available on our website as we speak are the ability to access for free as open resource all 4 units you see in front of you on this slide. So there are 2 that are lower elementary or K2. We're going to design engineer bandages. We're going to engineer sails, and we'll talk about those in a little bit. And then at our upper elementary or 3-5, we have engineering sock assistive devices and the engineering rescue shuttles that we just went through. So each of these engineering units start with an introduction to the engineering design process. At the lower elementary level, this is set up with Julie, who you see as an illustration here, and a read aloud story. And then upper elementary, youth meet Omar through a comic where he is asking for help with his messy backpack, just like Julie is. Both challenges give criteria and constraints and have students complete each phase of the engineering design process in about a 45-minute activity to set them up for then this larger design challenge, whether it's rescue shuttles or one of the others that we'll talk about. However, the challenges are set to be developmentally appropriate with slightly more materials available to the upper elementary students. And we can see here the print materials are slightly different. So we're going to watch a quick video of two students engaging in the design process here as they plan their pencil case in Spanish.
I'm looking at you, I'm gonna collect your packet, and I'm gonna look at your design, so there'll be a design on your face. That's your exit ticket. I'm collecting your packet. This is your exit ticket out of class. I'm collecting your packets, and I'm looking at your design, so design on your page. This is your exit ticket. I don't know why you have on your side.
So we see these two students leveraging their assets here. They're engaging with one another in their home language. They are both emergent multilingual learners. And our young lady on the left has a limited grasp of English in how she speaks. I did not hear her speak English the entire time we were in the classroom for 2 weeks. But the little girl on the right has a fairly bilingual oral language grasp. Now, where we also want to think about these asset-based pedagogies, again, is that familiarity with materials, tasks, and terminology. And so we have their engineering notebook snippets again on the right side of the screen. And on the top, that is literally the design that they drew immediately after this video. As they put that down, they started to draw and they made that. And you can see it, right? You can see those multimodal representations, the gestures that they were using combined with the drawing that's there and the labeling that happens to make this model. But we also see that there's some non-normative spelling happening, as does happen in our elementary students. But then we see their final design for their sock assistive device on the bottom of the screen. And that non-normative spelling has gone away. Why did that happen? Why did we get miraculously better spelling over the course of 2 weeks? No, they had a tool. And so one of the tools that's built into these is this materials glossary. And they weren't given out the first day with that pencil case activity, but then they were given out in the following days. And so the students were able to become familiar with the names and the spelling of these tools that they were going to use in their design. In some cases, it's just students might not be familiar with it, or they might be familiar but not know the name. So something like a dowel, they'll understand it's a stick, but we want to give them the access to the technical name for those things. It also just helps with spelling. And in some cases, it helps to make sure that everybody is talking about the same material. So for example, the craft sticks might also be called a popsicle stick. They might also be called a tongue depressor by a student. There's a couple of different names students might employ. By having this materials glossary, it gives them that common language to make sure that they're communicating effectively. And so then it allows all students to participate in the design. Am I gonna, oh, there we go. So to look at the first of these lower elementary out of school units is engineering bandages. And so again, we'll see that same format that we saw in engineering rescue shuttles, in that we have our what is the engineering design process, and then in activities 2 through 5, they're going through that engineering design process in order to design a bandage, because what little kid doesn't like bandages? They just think they are the greatest thing and they want to put them on all the time. Great, you can make your own now. We don't have to go buy them at the store. And so they're thinking about exploring the materials that are sticky, that will be good for sopping up blood. And then we have those supplemental activities that expand on that engineering design challenges, where they might decorate a bandage, or as we see in this picture on the right-hand side, they're thinking about designing a bandage for a finger, right? Fingers are different than other parts in that they bend. And so we have this model of a finger where she's exploring whether the cut can be seen as she bends or not. They employ those math skills in collecting data on bandage use, and there's a showcase in there as well. And so each unit has supports in place to make students familiar with terminology, tasks, and tools, and that scaffold students' literacy skills. Pictures, illustrations, and icons are used to support students in reading the materials, like the instructions here for testing their bandage. For our younger learners, the materials are simple to support access, such as opting for the illustrated poster story to set the context over the graphic novel we saw with the upper elementary students. So we see our characters from the poster. They would then be placed into the scene. And all of the units provide these visual vocabulary cards, which you'll see in the upper right hand, that can be shown on the screen or posted in the room to support students' use of terminology that might be new to them, like in this case, the word engineer. That might be a new word, especially to our K2s, right? They're just learning words to begin with. Engineer is probably a new word to them. Students, families, and communities are critical support networks in building students' positive identity development and confidence. We provide ways to help connect families with the curriculum through family letters, which you'll see on the left-hand side of the screen, and tips such as taking photos or videos at key points to share with families. That's in the educator guide, which we will look at a little bit later. This helps families see engineering is all around them. It provides supports for families to advocate for their students' STEM learning and possible STEM careers. It gives opportunities for families to engage as problem solvers, all while honoring their knowledge and experiences. And every out of school time unit has that showcase as part of the supplemental activities. And it comes with this template for sharing with families and community members about the showcase. This helps students to identify as engineers and highlight their success in the engineering program. So I just thought we'd pause really quickly and think about, in our own programs, what are some community resources that we might reach out to in supporting engineering? Are there local colleges? Are there industry in your area that might have engineers or might have other folks connected to the problem that may not be engineers? So I don't know if anybody has any thoughts or ideas.
I'm thinking about the assistive device with the socks, and at least in the part of the country where I am in the Midwest, even in very small towns, there's assisted living situations for aging parents, grandparents, and I think that might be an interesting group to connect to. They're not engineers, but they can help kids understand the problem and can give them that community connection.
Yeah, absolutely.
I was going to say where I live, I was thinking more about the rockets one, but because where I live, there's a very strong aerospace industry. And I was thinking about this sort of tying back to the engineering identity piece and, connecting with engineers at those companies who might represent a variety or diversity of children. So youth can, sort of build that, like, I can see myself as an engineer kind of thing. And we are very lucky to have that. So I could see if I was teaching this in an after school class or in a classroom, that I would want to reach out to a variety of engineers to talk about this, because shooting up rockets is something that happens around here. Like, that is something that people work on, which is pretty cool.
It is. And so in each of these units, if getting the community to come in, isn't a resource that is readily available, or we also heard from programs that, like, they're not allowed to have people in. So one is you could Zoom with them, you could bring them in on the screen. But we also provide videos to engineers of a wide variety of backgrounds, that students might be able to find someone who looks like them, who has a name like them, who maybe comes from a similar community that they come from, so that we do highlight, exactly like Becky was saying, that, oh, I can be an engineer because they are like me and they are an engineer. So yeah, leveraging some of those community assets. In some cases, you have parents that you don't even know that that's what they do. The one little girl in our interviews in Puerto Rico talked extensively about her uncle who was an engineer. And when I mentioned it to the teacher later, she had no idea that this child had an engineer who was, in the family. And so now she knows that. She's like, oh, I will be reaching out through those parents to see if we can get the uncle to come in and talk about what it is that he does right there in their community. He was somebody that lived nearby. So that family letter kind of helps to start those conversations too, I think. So our other K-2 lower elementary unit that we have right now is engineering sales. And this was a lot of fun for students because we're thinking about the problem of, I have a friend who lives next door and we want to share our little scoobles, as we call them. So kind of little stuffed animals or figures. And we want to send them back and forth using the power of the wind. And so again, they start with their pencil case design, but then they go through and explore the different sail materials and how we can use the wind to move things around. And then they do have these, again, the supplemental activities. So for instance, in this one, they're thinking about how we might design the sail to go faster, right? If we want to think about speed, or to carry more stuff. And so we see two little girls here. They're working on their planning together. So we see this kind of simplified planning page that they have there, but also the little piece of their sail. They have the little cup that's going to hold their scoobles eventually. And so this is where that developmentally appropriate really comes into play. These materials look different than the ones that we saw in rescue shuttles. Our Imagine page is really simple. It's just spaces for children to draw or write their ideas. And we see this is from that designing for the speed. This is their testing page. And so there's a space for each participant to write their name and then just simply write down the time that it took for the sail to get across as they go through their different trials. Very simple, but then there's that applying mathematics again. They're thinking about time. Reading a clock is a very key skill that we need our K-2s to be able to do. And so one of the key really important resources that we have that is part of this open resource is our educator guide. And so this can be downloaded from our website as a PDF. And so I've given 2 sample pages from sales here in order to talk about this educative curriculum material and the way that it supports educators in engaging students in these equity-oriented framework practices that we've seen. So we're going to just quickly go through some of these that really help educators to get students engaged in this engineering practice process. So one is that we're thinking about clear objectives and highlighting an engineering practice. So this is from activity 2 in engineering sales, where they're thinking about identifying the problem. What is the problem? And so they're thinking about learning how the wind can move things. And that engineering practice is that considering problems in context. They're going to meet their little poster characters and the problem that they have. And we've thought about using really simple everyday materials. If you look at this list, there's nothing on here that isn't something you as an educator are already familiar with at the K-5 level. Straws, felt, cardboard. These are all things that some of us have in our classrooms already that we're used to using with youth and that youth might really be familiar with. But we also make it clear exactly what is needed to complete that activity on that day. How many we need per group, per class. What do I need to print out? Which posters am I using that day? So that educators can prepare ahead of time and feel ready to walk in that day and work with students instead of worrying about what materials I need and where they are. As we get into the curriculum, we know that there's a wide variety of experience and expertise in our out-of-school time educators. And so we really think about giving more information than maybe an educator would need so that everybody feels supported and is learning as they go through. So we have these step-by-step instructions, and they include question prompts, so things that you can ask students to help facilitate these conversations, to engage them in the practices. So in this case, we're asking students, how did your group, we're asking them to share out and engage in that communication. And then in order to get that equity-oriented framework really present within there, we have these embedded tips. And so we see the one on the bottom is just sort of, if your students are done early, if they need an extra challenge. But the one on the top is really highlighting ways to promote equity. In this case, maybe we need to review some of that vocabulary because it may not be familiar to all students. So let's make sure that everybody has that reminder and refresher of what that term might be. And so the final unit that we have is our engineering SOC assistive devices. And so we see again, there's our engineering design process introduction. And then students are thinking about asking, imagining, and planning together as they think about how I hold open a SOC, how I can pull a SOC on, because the context here is that students are designing a SOC assistive device to help somebody who has a broken leg and can't pull their SOC on themselves because they can't bend their leg. They create, test, and improve that. And then in these supplemental activities, we're really thinking about accessibility. We're thinking about looking into our own programs. What parts of our space that we exist in are accessible to all students, to all participants, to all visitors? They're thinking about engineering another device. So we've talked through the main challenge about pulling on a SOC to our feet. So now we're thinking about a kitchen utensil that maybe somebody who doesn't have both hands, who doesn't have hands at all, who doesn't have the strength to use some of these utensils, how can we make this easier for them to do? And we give them choices there again of what device, what utensil do they want to deal with? We look at those, the idea of playgrounds and how can they think about redesigning the playground that is near them, whether that's on the property of the school that they're at or the facility that they're at, and thinking about making that accessible to all of these kinds of people that they've been meeting along the way through this unit who maybe don't have access to the playground in the way that it exists. And we again have those career connections and showcase like we saw in rescue shows. So we just wanted to highlight again these criteria and constraints to just show them a little bit in a different way. So we have a planning page on the left. This is in that improve phase. So they're thinking about what they need to make better as they're planning for their improvement. And, you know, they're thinking about those criteria and constraints. Their goal is to design a sock aid to help people put on their socks. And we do have these criteria and constraints. Criteria, hold it open. Hold the sock on the foot, let go of the sock. And that feels really simple, but it really does challenge students to think about the ways that this could be done. And their constraints are that they can only reach to their knee. They can't put their hands past there, and they can only use the materials we gave them. You cannot bring in a, you know, spring-loaded whatever to help pull the sock up. You can only have what's available to you. And so those parameters are there. But we've also seen educators slightly change these or add things that are important to the students as these things come up. So ideas that students come up with as criteria or constraints, again, building on those assets. And so even with these criteria and constraints, the design challenge is still open to interpretation by the youth. We see a variety of SOC-assisted devices created by students across multiple programs. And much like engineers, the students have found more than one way to solve their problem, even with the limited materials that we have given them. Another great tool that is, again, available right now on the website you can get to is educators' slides. So this is scaffolding for the educators. Pre-prepared instructional slides that help the educator focus on the important parts of teaching the students. These are useful if you have access to a projector, but we also know that not all of our school settings do. And you can share these same resources in print format or send the materials out to student devices like iPads and Chromebooks. The flexibility is built in for different types of out-of-school contexts. And so we see the comic is on the slides that you're able to read those. We also see places, now that's from sales, of the problem and solution chart. So thinking about what's the problem and what are solutions we're coming up with. There's those talk prompts again, so ways that we are thinking about discussing and engaging in communication. And just instructions for students, reminders of, in this case, how are we launching our rescue shuttle? So within SOC aids, this idea of accessibility all around us really helps highlight this socially engaged engineering idea of consider the impacts of the problem on different individuals, groups, or systems. And so we have on the left some ways that they've thought about different people who might need access to the space if they don't already know those. And on the left, really simple ways of them thinking about different tasks these users may need to do in order to access the space. And so the picture that we see in the center is actually of a program here in Pennsylvania that is an after-school program that focuses on people with disabilities. And so they had this added bonus of having some of these tools that they were able to really pull on their community right there with them. They looked at a Braille creating machine and how that gave access to materials to their peers or to other people in the program. And in this case, they borrowed the wheelchair that belongs to the program and took turns being wheeled around and seeing how they might be able to or not be able to access different components of the space. They had a shared space that was not all part of their program for people with disabilities. So they were able to kind of make some comparisons between the way that their individual space was set up and how pieces of the rest of the building were set up in ways that maybe weren't as accessible. And so we thought we'd pause here and say, what questions do you still have around equity-oriented engineering and or the YES out-of-school time units? And if not, we can keep moving, but that was my pause and let you ask questions before we keep going.
I don't have a specific question on OST, but I do have a question. I was thinking about this particularly with respect to the unit you were just talking about with accessibility. And this has come up a lot recently where is there, and you may not have an answer for this, so I will accept that. When you are with a group of kids and you are proposing a certain activity, and then you realize that one of the kids might be actually affected by the thing that you're talking about, and with accessibility that can come up. Like, I don't want to isolate those kids or make them the explainer or the point of attention, but I'm also thinking about it more broadly, and this has come up in more recent conversations where we talk about kids in Gaza not having enough food right now, and aid drops, and or the bridge that just collapsed in Baltimore, that might, those might bring up some emotions around the engineering, or in my community, wildfire is an issue. We would never want to do anything. And so I'm wondering if you have some thoughts about how to tackle those challenges in engineering spaces with youth.
So it's curious that you say that you wouldn't want to talk about wildfires, because that feels very similar to me to what's happening with this group in Puerto Rico. And I will say that when it's a community problem that affects them, that empathy and that affect that goes along with the engineering really comes out. And that, I think, is one that that's really important to highlight, that getting away from this idea that science is static and unaffected by people, we really are trying to highlight that. When it comes to sort of this individual discrepancies within the room, I will say that with SOC assistive devices, we try to highlight the very simple devices along the way that all students are kind of seeing. So one of the ones that we bring up in the curriculum is the idea of glasses, and that glasses are an assistive device. And so it doesn't have to be I'm in a wheelchair or I have an artificial limb. It's like, hey, you a lot of people in this room have a need for some type of assistive device, or bringing in, you know, family members or things like that. When we started talking about these sock assistive devices, in the one school, we heard a lot from students about grandparents that live with them that could really use this, or have some version of actually already a device that helps them put their socks and shoes on because of a variety of different things, whether they had had an injury, some of them had, you know, just from old age had lost some of their flexibility. So there is that being aware, and this doesn't come from engineering, but we had this with another project that I was working with, where we had looked for, they were designing toys, and there was this concern with some immigrant populations, if we wanted to show these videos of kids designing toys in Africa that were using like basically recycled materials, which is kind of what that activity was going to do, that would that be upsetting for students to see? And so thinking about the context setting, and that's where sort of the educator professionalism comes in too, of knowing your youth in your program, and knowing that sometimes you might upset a kid in the way, along the way. When we had the tsunami, oh my gosh, that was very, very long ago. But I was like, this is a great teaching opportunity. And I had sixth graders in tears, and I was like, whoops, well, that might not have been the way to go about it, because we were watching some of these news footage videos to be able to contextualize the science we were going to talk about. I had misjudged the sensitivity of some of these students, and we did have that. So I think it's sort of that, like, how far can you push in knowing your youth in your program a little bit when you get to that, but also not undercounting that we do want them to have emotions attached to this, that's sort of where the contextualization comes in, is we want them to feel something.
I would absolutely agree with that. And I will say, you know, like for my own community, it was like that the trauma, the fire, we couldn't do anything very close to it. It happened, but it's been 3 years now. And so we're at the point now where we see the positive things happening, and we're starting to see activities come out where kids are, like, say, talking about how to design around their houses to protect it from fire. What materials do we use? And so it's starting to be a productive thing, but certainly, like, and this happened when the bridge failed this last week, and I was thinking about this, I was like, ooh, this is going to be challenging for kids in the Baltimore area.
Right.
To be building
Maybe
bridges
not
at any
tomorrow.
point.
We're not gonna
Right.
attack
that
that
there's like a
problem.
time, like, let's let things
Yeah.
heal a little bit. And I guess I
Yes.
wanted to surface that point and just know if you had any particular
Absolutely.
insight. So thank you for sharing your insight. I very much appreciate that.
Yeah, I think a little bit of distance. And it's also, some of these are like, so the Puerto Rico context, it was all the time. Like, these things just happened fairly frequently. The flooding
Part
was
of their life.
It's just part, right. So it's not this sort of re-traumatization as they're going along. It's just like, hey, this happens and we need to be prepared for it. So I think there's that, is it a one-time, right? Like this bridge collapsing in Baltimore, hopefully is a one-off situation and isn't going to happen again. So giving it a little distance, I think, to heal from that can be, yeah, really critical before diving into solving the problem. So we'll wrap up here. I just want to show, nope, try that again. There we go. How to get to our resources. So the website is there really simply, yes.mos.org, and that'll take you to our homepage. And so on the left there, you'll see a screenshot from the homepage where each of the 3 curricular modules are there. And if you click on our out of school units, it'll take you to some graphics to represent each of those. And when you click on them, you'll get much more information about each of the units. And then on the far right-hand side, you'll see where you can purchase materials or download the unit. And so to purchase materials would take you to a place where, if you would like the big box of materials to be there, easily ready for teachers and educators to use, that will take you to the store where you can purchase that, or print copies of the educator guide. If you go to the download unit, that will get you to a Google Drive where you can either download the materials, the digital materials, so the PDFs of the educator guide, the teacher slides, the student-facing materials, or copy them to your own Google Drive from there, which I do highly recommend just copying them over, especially the slides, because those going from Google Slides to PowerPoint can get a little funky with formatting from time to time. I think most people are familiar with this challenge. So those are there. And I see Sandra also put the link right directly in where you can get to that curriculum page. And so I thought I'd just wrap up with, we have this lovely video of some educators talking about how beneficial this was for their students to engage with YES. So I just thought I'd let us kind of wrap up there with them talking and see more kids doing engineering. Boop, boop, boop. There we
Yeah,
go.
one of the materials within the YES program that we used a lot was the materials list, where they got to some of the materials they didn't know the name for, so they were able to look at the pictures, then make the connection between the name, and then by the end of the unit, they were able to identify them by their name. So the pictures there really helped. The captions, the side little notes within their resources and their materials, and then also guiding things for the teacher to help add to their lessons in case needed. There were definitely a lot of supports, which was great.
I love the fact that it provided all of the sentence stems for students. I think that was kind of invaluable because even with our regular learners, having that kind of starter to know how to not only write their answers, but then also communicate their answers with their peers. So I noticed that our English language learners were very engaged in their projects. They were able to communicate their ideas through drawings and using the sentence stems. So within those packets, I love that they had the opportunity to draw out their ideas, write their ideas if they're comfortable with writing. If they're not comfortable with writing at this point, they're able to communicate it with their peers. So it really gives every student the opportunity to express their ideas in a way that they're comfortable to express their ideas.
All right. And so we'll just wrap up with just a slide about, are there any questions that Christine or I can answer for you? You have our email addresses there as well. So the yes@mos.org will get you to sort of people who can answer general questions for you if you just have questions about ordering materials. But if you wanted to speak with Christine or I directly, you could reach out to us. And then that QR code and web link will take you to our upcoming events. So we are hosting a webinar at the end of April on uncertainty and failure and students' mental health in STEM. And we also have our Teacher Educator Institute and workshops that are in person at the museum that you can attend. That's it.
Fantastic. And then if you don't mind, I'm going to throw up a set of slides of our own
Absolutely.
as we wrap things up. First of all, just really want to say thank you so much. I am so impressed with this curriculum and deeply wish I had a class to work with in Snagit, but I will certainly be sharing this widely. Here, let me throw up my slides here really quick just so we can talk about what's coming up in our world. There we go. Sandra, do you want to talk about our upcoming webinars here really quick? You're muted.
Thank you. I'll drop some links in the chat real quick too. We have the next Click to Engineering webinar is engaging all learners in engineering. That'll be April 24th. And it's really along some of those things we were just talking about how do you adapt to meet the needs of different learners that are in your program. So how do we make it engineering something that everybody can do? And what difference does that make? And, when we're thinking about engineering being about solving problems, people who have disabilities, who have physical limitations may approach problems differently. So having different perspectives coming into the problem solving space is really important. So those are some of the things we'll be talking about on April 24th. And then our next Click to Computer Science virtual workshop will be about teens leading in computer science and some new resources we're developing for teens who are teaching or volunteering as teachers in this out of school time space and how we can support teens who are leading. And then I also will put in a link. National 4-H Council on April 10th has a positive youth development immersion into computer science that is really connecting, supporting youth development and computer science, and has some great new resources around 4-H approach to computer science. And that is not our project, but we're partnering with National 4-H Council in the, and so I wanted to let people know that that was coming up as well. And all of these are things that are currently on our website or will be on our website within the next couple of days. So you can always go to the blogs for Click to Engineering or Click to Computer Science to find these resources as well.
Which is also where you will be able to find the recording of this video, should you want to watch it again or catch parts that you missed. And then just, our final thing, if you need to get a hold of one of us, feel free to connect with us online virtually, or shoot me an email, and I'm always happy to chat with people for pretty much any reason around engineering. And then if you have a moment, please do fill out our post-session feedback survey. There we go. And let us know what you think of how we're doing and how we could possibly help you more. So thanks so much for joining us today. And Sandra, I think we can go ahead and stop our recording unless Katie or Christine have any final words for us.
No, just glad that we can share what we're working on, and we